Hello everyone and welcome back. So, let's start with a very important question. This is in fact one of the most important questions of the entire course. What is an API? API stands for Application Programming Interface. And in general terms, an API is a set of clearly defined methods of communication between different software components. A good API makes it easier to develop software by providing all the building blocks, which are then put together by developers. As a matter of fact, an API declares an interface that allows us to interact with its logic without having to know what happens, as the saying goes, under the hood. And APIs are everywhere, really. Operating systems, programs, programming languages and software libraries, the web, of course, computer hardware, and so on. Therefore, there are different kinds of API. In this course, we're going to talk about web APIs. You can think about web APIs as a set of protocols for communication between either different web applications or different parts of the same application, and that allow external clients, such as, for example, a smartphone app, to connect and communicate with our web app. The most common kind of web API nowadays is REST, and the APIs that we're going to build in this course are going to be REST APIs, or as some developers like to call them, RESTful APIs. We will talk about REST and its features in the next lesson. Now it's very important to answer the following questions first. Why would we want to develop an API in the first place? What are APIs really useful for? Well, let's take as example two very important companies, okay? Instagram and Twitter. They both have an official website you can access from the browser, of course, and they also provide applications for smartphones with different operating systems, such as Android and iOS. And each one of these applications has access to the same synchronized contents. Without a web API, a basic architecture for a similar web service may look like the one shown in this diagram. Each client app has its own embedded business logic, most likely written with a specific programming language, connecting then directly to the database to get and manipulate data. Maintaining and scaling a web service that uses such an architecture could easily become very challenging, as for each new feature you might want to add to your web service, you would have to update each app accordingly, of course. And this can be a very expensive and error-prone process, which often leads to bugs, feature fragmentation, and overall project delays, which we never want to have. APIs allow us to build a much more powerful architecture instead. Let's have a look. Using an API-first approach, the development process gets much easier and faster. The API provides a common interface that can be used by all the client applications to interact with its own business logic, so that each app has feature parity, and if you need to implement a new feature or maybe an update, you just make it in one place. The apps themselves will then simply become the user interface layer of a service we're providing to our users. With such an architecture, it's important for the different parts of our application to communicate with each other using a standard file format that should be both human readable and fast for computers to process. One of the most common file formats used by APIs is JSON, where JSON stands for JavaScript Object Notation. And the JSON object is a list, a set of key value pairs surrounded by curly braces. So this is an example of a simple JSON object for a service like could be Twitter, for example. As we've mentioned, it's a set of key value pairs surrounded by curly braces. And of course, as we can see, this is both human readable and pretty fast for computers to process, because let's say that our front-end client needs to show the creation date for this, that could be like a tweet object, okay? It can just reference the created@ key to know the exact date of creation of our tweet. And as we can see in this specific example, we are using strings. Each key is assigned to a string. But if we need to, of course, we can use more structured data types, like for example lists. So in this example we see that to make it easier for our client and overall to make our application more performant, okay, we are using a new key, hashtags, that we've assigned to an array, a list of the hashtags used on the same tweet object. And if we want to, we can even get more advanced. For example, here we see a JSON object nested within another JSON object. So that, for example, if I needed to know the location of the specific user that has written that specific tweet instance, I would just have to reference user and then, of course, location to know it without having to make another request to our REST API, okay? Now that we've got an idea of what a web API is and what file format to use with it, we might ask ourselves, how can we get access and interact with the API? What sort of channel or access point should we use? We can access our APIs using the so-called endpoints, typically URL patterns that we can use to specify what particular information or service we want to access, using the file format that is used by the API. So for instance, going to /tweets could give us an API JSON response containing a list with all the tweets of, for example, our tweets feed at a particular moment in time in the system, okay? We might go to /tweets / a primary key like 536723, for example, to grab the details of a specific instance. We could also go to /tweets / the same primary key /hashtags / to get maybe a list of all the hashtags of that same tweet object. Same thing we could do for the details of the user that owns that tweet instance. In the next lecture, we're going to continue our discussion about APIs, get into the details of the technical implementation of a specific kind of API that we're going to build throughout the course. As we said, REST APIs. This will also give us the opportunity to talk about two very important related topics, HTTP and status codes. So, see you in the next lecture.